In the given truss problem, we have to calculate the vertical deflection of joint E. For calculating this deflection, we will use the virtual work method. Let's have a brief intro about the principle of virtual work. In this method, we deal with the real system and a virtual system. In real system, we calculate the stress in each of the truss member, and in a virtual system, we remove all the real applied loads and apply a unit load at a point where we have to calculate the deflection. And in a similar manner, we here also calculate the stresses in each truss member. And the virtual work, the internal virtual work would be equals to energy density into volume. And hence the internal virtual work comes out to be stress in a real system and stress into of a virtual system multiplied by length upon AE. A is the area and E is the modulus of elasticity. And the external virtual work would be equals to the force into displacement, the deflection which we need to calculate. As F is arbitrary, for simplicity, we assume it to be a unit load. And according to the principle of virtual work, the external virtual work should be equal to internal virtual work, and hence the deflection would come out to be the summation of internal virtual work across all the truss members. This would be the formula of deflection which would be used in our problem. So first we consider a real system and we calculate the support reactions by applying equilibrium conditions in the x and y directions and a moment balance about A. By doing so, we can easily calculate the support reactions at A and B. And after that, we will calculate the forces in each of the truss member by applying a joint equilibriums at all the joints. First, we have applied joint equilibrium at A, and by applying x and y directions equilibrium, we can calculate the forces in the truss members AC and AF. The negative sign indicates that it is compressive in nature, as initially we have assumed all the forces to be tensile. Hence, the negative is compressive, whereas the positive we would consider tensile in nature. And in a similar manner, we can calculate all the forces in the truss members by applying joint equilibriums at C and F, E and B. And after finding all these forces in the joint in the truss members, we will enter into a virtual system by applying a unit load at the position we have to find the deflection. Here, in case it is a point E, and we would remove all the applied loads in a real system which were applied at C and F. And again, we would calculate the support reactions by applying force balance and a moment balance. And then in a similar way as in case of a real system, we will calculate here the joint equilibriums, and at joint equilibriums we will calculate the forces in the truss members, and by applying all the equilibrium conditions at all the joints. After finding all the forces in the truss members, we would plug all the values in the given formula of this deflection. Here Ni indicates the actual forces in of the truss member in the virtual system, and capital Ni indicates the actual force in a truss member in a real system, and Li indicates the length of that particular truss member. For the simplicity of calculation, we have tabulate all the calculations and multiplied Ni, small ni, capital Li, and by summing up, we would get the vertical deflection at joint E. The positive sign indicates that the deflection would be in the direction of the applied unit load. Here, we have applied the unit load in the downward direction, hence the deflection of E would be in the downward direction.